In this very last video, I will go over how to find the domain of this logarithmic function, a nasty looking rational argument. So, alright, this is going to take some work. It's a great review problem of section 2.6. So I'll copy this and I'll just start a brand new page with this. Okay, so let's find the domain. Well, setting up this domain problem is easy. You just grab that argument and say that needs to be greater than 0. So say -5 over x plus 5 is greater than 0. And you know what? This is actually a good problem for, I guess, final exam, because it's not only asking you, do you know how to find the domain of a rational, not rational, what's it called? Logarithmic function, but it's also asking you, do you know how to solve this rational inequality? So this is a great review problem for section 2.6. So let's get us started. Well, what do? You have to find the 0 of the numerator. Find zeros of numerator, stop, shh, and denominator. Okay, you have to find what value makes the top of the fraction 0 and what value makes the bottom of the fraction 0. If you look at the top of the fraction, though, on top of the fraction there is -5. So, can -5 be equal to 0? No, right? So there is no 0 of numerator. So pass. Next one, look at the denominator. Can we have 0 in the bottom of the fraction? It looks like x equals -5 will make that. So I'll say x equals, or you can say x plus 5 equals 0. And that's going to give you x equals -5. Stop it. Is the only 0 of the numerator and the denominator. So that's the only number that we're going to have to test. So draw a number line. Put that -5 in the middle. Let's check the sign to the left and to the right of -5. So I will plug in a number that's smaller than -5. X equals -6 into this inequality to see if that is true. So, -5 over -6 plus 5. Is that greater than 0? Shh. Is that greater than 0? Let's see. That is -5 divided by -1. Is that greater than 0? Yes, it is, because +5 is greater than 0. So this is true. Why is she singing like that? I have no idea. Okay, so that is the answer region. By the way, I forgot to plot a circle. Now listen, you guys. X equals -5 is 0 of the denominator, wasn't it? So you must plot an open circle. Let me go ahead and zoom in so that you can see. You must plot an open circle, because technically we can never have that value. It's just a great boundary point for us to check the sign to the left and sign to the right. But we can never really have that value. So what I'm going to do is I'm going to draw a number. Ignore that noise. All the way to the left of -5 is a solution. Now I'm going to check the other region, but I have a strong feeling it's going to be false. Plug in a number that is greater than -5. I can plug in x equals -4. 0 would have been a nice one too. But if I plug in -4 into this equation or inequality, I will get -5 over -4 plus 5 is greater than or equal to 0. Let's see if this is true. That is -5 over +1 is greater than or equal to 0. Oh my goodness, it is saying -5 is greater than 0. This is false. Because this is false, area or interval to the right side of -5 is not the solution. So, what is the domain? Okay, I'll go ahead and write the final answer. The name of this function is f. Domain of f of x is from negative, Shouldn't probably do an equal sign. I'm so distracted. Domain of f of x is, or just f is, from -infinity to -5, close the parenthesis. So by setting the argument greater than 0 and then solving, in this case it was a rational inequality, great review of section 2.6, or in the previous one we had to solve a polynomial inequality, we can find domain of logarithmic functions. But these two examples, C and D, that I just showed you were a little more difficult than part A and B, but they were great review problems because we get to look at solving polynomial inequality and rational inequality. So I hope this was helpful on your ALEKS homework this week.